for joining our discussion today. We're going to talk about some tips when we're talking about migrating data warehouses to Azure. We've got a lot of good information on this topic, and I hope you enjoy it. If you have any questions, of course, during the session, if you can put them in the chat window, and then I'll try to get to as many as we can at the end of the session. A brief agenda for today. To frame up our discussion, I'm going to lay out a sample scenario, just a simple technical architecture that we're going to talk about as an example for when we're talking about our migration today. And then we'll spend a little bit of time on each of the topics below related to migrating a data warehouse to Azure. So beginning with database objects, we'll talk a lot about data migration, and then finishing with the ETL and reports, and then finally that last switch over. My name is Bob Rubaki, and I'm a practice manager and consultant with Pragmatic Works. You can reach me at any of the methods I've listed here. Email works pretty well if you want to reach out to me afterwards with questions, etc. I'd be glad to talk with you. So to frame up our discussion today of migrating data warehouses to Azure, I want to use the following scenario as an example, and I'll kind of refer to this as we talk about some of the considerations for migrating a data warehouse to Azure. So I want to talk about the scenario to kind of cover a couple of assumptions about the size of data and the type of workload that we have. And I think that some of the points that I'll make down later in the talk will make a little bit more sense if we consider this scenario going forward. So to begin with, I want to talk about what I've labeled as the existing DW, kind of in the top middle of the screen there. So we're starting with an existing data warehouse. This data warehouse can be on any platform, really. And so what I want to talk about today will be considerations for migrating from any platform. This is not going to be specific to migrating from a certain platform. And so we've worked with customers who are trying to migrate SQL data warehouses from an on-prem environment, for example, and moving that to the cloud. But also a lot of customers who are interested in moving off of Teradata or Netezza, for example. And of course, Oracle. We see a fair amount of that as well. And so we want to assume that for right now, we've got an existing data warehouse and that we are moving to a SQL Server version in the cloud. And I'm going to talk a little bit in a second about some of the options that we have for SQL Server in the cloud, but I want to make that assumption for our discussion today. A big driver of some of the scenarios and the tips that I'm going to talk about today really have the assumption that when I'm doing this migration of a data warehouse, that I want to minimize the amount of downtime required during that switchover. And so some of the tips that we'll talk about today really are going to focus on that requirement, and we'll get into that shortly. As far as data volume, I put the number of 200 gigs as kind of a rough estimate. The reason I'm calling that out is that some of the techniques that I'm going to suggest or describe later really apply to larger data volumes. If we had data volumes less than 200 gigabytes, I might use a simpler, more lightweight approach. But for the purposes of today's discussion, being that we're talking about data warehouses and those can certainly grow to be very large, I'm going to just assume that we are working in data warehouse type volume. 200 gigs, of course, in the grand scheme of things is quite small, and we'll talk about what that means here shortly as well. But again, I just want to make that assumption that I'm dealing with a size of data that's not just a simple, copy, paste, backup, and restore type scenario. So the first thing we really want to consider when we are migrating to SQL in the cloud is, holy smokes, there are a lot of different options when it comes to migrating to SQL in the cloud. And so I've listed out kind of four the biggest or primary options to consider when we're talking about migrating to SQL in the cloud. I'm going to start on the right side talking about what we call IaaS, or infrastructure as a service. And this is really running SQL Server on virtual machines that are running in Azure. So that's one option that we can consider there. Running SQL Server on a virtual machine means I've got full SQL feature compatibility. It's running on a server in the cloud rather than on your on-premises environment. You've got full features, everything that you can do in SQL on-prem, you can do on a VM. Of course, you are then managing that VM, all of the security, all the patching, and all that kind of stuff. Typically, what we prefer today are one of the options on the left, which are called Platform as a Service. And what this really means is that we don't have dedicated server resources. It's a managed service for us in the cloud. So that means things like automatic backups and data redundancy kind of native to the platform. And so we generally prefer moving customers to one of the Platform as a Service options there. And I've called out 3 of them. Azure SQL Managed Instance, and I'll talk about these in a second. The single database, or what is now known as Synapse Analytics, which used to be Azure SQL Data Warehouse. So I want to typically work to decide between one of those 3 options on the left, the Platform as a Service options. And as I consider those, these are just a couple basic considerations that I would use for making this determination. I'm actually going to start at the bottom in here. Managed instance typically is the least favorite of the 3 options. In other words, we prefer Azure SQL Database or Azure SQL Data Warehouse. Managed instance is really great if you are migrating a SQL Server database to Azure. Managed instance is a really good fit in that scenario. It's also a really good scenario if you really need full feature compatibility and parity with SQL in the cloud. The other 2 options, the SQL database and SQL DW, has what they call near feature parity. So there are some things that are not available in SQL database and SQL DW that you have in on-premises SQL Server. And if those things are important to you, then managed instance is going to be a good suggestion. And again, if you're migrating a SQL Server database, managed instance is a good consideration there. Part of the reason for that is that with managed instance, I can, depending upon the kind of the data volume that I have, do a backup and a restore of an on-premises database to managed instance. But if I'm choosing between SQL Database and SQL DW, a couple of guidelines are data size and the number of records that I have in my fact tables. SQL Data Warehouse or Synapse can work really with any size data warehouse, but it's particularly designed for larger data warehouses. And so that would be anything where your fact tables are at a minimum of 60 million rows or greater. And there's some underlying technical reasons for that number. But the point is that Synapse or Azure SQL Data Warehouse is really designed for those larger workloads. And it can take advantage of some compression algorithms and some query architecture on those larger data sets, particularly those that are over 60 million rows. SQL Database is a great product. It works very well. We're doing this with a number of customers today. It's typically going to work or be considered more when we're dealing with smaller data warehouse loads. So after we've decided which SQL platform to move to, one of the first things we're going to do during a migration is actually start to script out the objects and create the new objects on that target database. So typically we start with our tables because that's where all of our data is going to be stored. And a couple of the biggest things that we want to keep in mind as we're migrating tables are, particularly if we're assuming we're scripting out a DDL from our source system, regardless of what platform it is, we'll just have to keep in mind some occasional data type compatibility challenges. And then also when you're scripting out the tables from your DDL and we're recreating those in SQL, we'll just have to make sure, of course, that we're modifying those scripts to use SQL Server data types. So that's just one thing to to keep in mind. It's pretty obvious, but it's just a quick tip there. Also, if we're moving to Azure SQL Data Warehouse or Synapse, there are some additional table configurations that we need to consider if we're using that platform. And so there are some options that are set by default, but if we want some additional specific storage methods, for example, we're going to have to consider that during our design and our migration plan. Talking about views and stored procedures, this can be a pretty considerable amount of work. In particular, there are some, depending upon the platform you're coming from, of course, that you're going to have some slight SQL syntax differences. And so very frequently, we need to make changes to our store procedure syntax to use, T-SQL, SQL Server syntax. And of course, depending upon the number of stored procedures you have, that can be quite involved. So that's something to consider as you're looking to migrate your database. Another one that we come across pretty frequently and is a big consideration as we're doing migrations is that, generally speaking, on SQL Database and SQL Data Warehouse, we can't do cross-database joins in a query. I say generally there is a way to do it, but it's just not really ideal. And so that is something that is a big consideration during migration. If you have stored procedures that are querying data from other tables, from other databases, then the data in those databases may have to be considered in the migration as well to put it all in one database so that we can avoid those cross-database joins. And of course, as we move the data from other databases into the one database, that will then require changes to the code then to not use that cross-database join, but rather refer to a table that's in the database that we're migrating to. So probably the longest part of my talk here today is going to be about data migration. This is typically the piece that's the most complex and generally takes the longest time. It takes time in part because the process of extracting the data and moving it can be complex, but there's also time involved with just the sheer movement of the data from the existing data warehouse to Azure. And we'll talk more about that in a second. But pretty typically, the way that we approach this is we'll do a one-time full load of all of the data that's in the existing data warehouse and move it, which is my solid red arrow here, just move that data to the new data warehouse. I'll talk in a second about what happens with this red arrow here, because there is a lot happening here, but that's typically the approach that we would take. So we'll need to design a process and a methodology for taking that data from the existing warehouse and moving that to the new data warehouse. And again, thinking about our early assumption that we want to minimize any downtime to reports or applications that are using our data warehouse. If we understand that full load takes a considerable amount of time, that generally means downtime. And so I don't want to shut off the existing data warehouse and then do the full load, which might take days or weeks, and then switch everything over to use the new one. There's that lag there between the time that it takes to do the full load. And while the full load is going, we're still pumping new data into the data warehouse. And so very typically what we do is we'll design then a process to synchronize the existing data warehouse with the new data warehouse through like an incremental synchronization process. So for a period of time, data from your source systems is still being loaded into the existing data warehouse, and then just the deltas from that data warehouse then are loaded into your data warehouse. There are a couple different approaches for doing that, but in general, that's kind of how that will work. Getting into a little bit more detail on that one-time full load of data. Again, this is just migrating all the existing data from the data warehouse to the new data warehouse. And in general terms, we can do this in three primary steps. The first step is to take that data out of the existing data warehouse, and we pretty typically put this into files, either text delimited files or Parquet files. Parquet files are particularly good when you're talking about moving to data lake, which I'll talk about in a second. But they're also compressed, and so they help with just the sheer volume of data that we need to move from our existing environment up to Azure. So once I've extracted all of that data and put it into files, I need to move those files. We copy them up to data lake. And data lake is cloud-based file storage. And with the data in files, I can then move it into the respective data warehouse tables. But that's step number 2 of moving the data from what's pretty typically local storage, moving it up to Azure, is a pretty resource-intensive process, and generally is the piece here that can take the most time. And I'll talk about some tips for minimizing that time. But a common approach to doing this is to use the AZ copy utility that Microsoft has. It's a really great tool for doing that. I'll also talk about Data Box in a second as an option for migrating that file-based data up to data lake. I'll talk about that in a second, about what that means exactly. The third step then is, after the data files have been moved into data lake storage, we then use a process and write the process to import that data into the new data warehouse. Now, depending upon the database platform that we've selected, again, either Azure SQL Database or Synapse Azure SQL DW, the specific technique that we use there might vary, but the idea is still the same. I'm moving that data from those files into SQL Server table storage. Yeah, I'm going to move this out of the way for a second. So I talked about the time it takes to move data in those files from what's generally an on-premises environment up to Azure. Depending upon the data volume that you're working with, can take a considerable amount of time. This chart here was actually put together by Linda Wang, who's with Microsoft, and she actually presented this in her talk at Ignite last year. And so I've included a link to her talk there. If you search that Ignite 2019 talk, she's got a great talk about moving large volumes of data to Azure. She talked about Data Factory, but this particular piece here is just talking about the time it takes to move data from an on-premises environment to the cloud. And in her example, the red and the blue is kind of a guideline. The red was anything that was under 2 weeks, and the blue was anything that was over 2 weeks, and that's how she framed her demonstration. But as you can see, it very typically takes many, many days, in a lot of cases, to move large volumes of data. So for example, if I had a 10 terabyte data warehouse and I'm moving that over a 100 megabit connection, the math there says that's going to take almost 10 days just to move that data from point A to point B. And so we'll talk here in a second about some ways to reduce or minimize that time, but just want to point out at this point in the talk that the process of moving that data to Azure is very time consuming and resource intensive. Now, one thing that we can do to help with that timing is by using Azure Express Route. And I'll jump to my last bullet point there. The reason we would use Azure Express Route in this case here is because it is fast. It is a dedicated connection between your environment, which I'm assuming here will be on premises for this point of the talk. It's a secure, dedicated connection from your environment to Azure. And you can provision connection speeds that are listed there. So I can go all the way up to a 10 gig connection, which is really going to help with that, of course, that transfer rate. Another nice thing about Express Route is that the connections are redundant in that if the connection breaks for any reason, there's actually a failover connection to help continue my processing. So it's really designed to be very durable and stable, and not have any interruptions in that data transfer. So that's another reason we would want to consider using ExpressRoute. And again, this is, if I use AZ copy to move data from my on-premises environment, if I have that configured to use ExpressRoute, I can expect to get those speeds that I've listed here as long as I've provisioned my ExpressRoute accordingly. I'm getting a note here about audio difficulties. Crystal, are we having any problems right now with the audio? I'm called in from my phone, so I'm not sure if we're having challenges there. So I will keep going. Another technique for getting that file-based data from my local storage to the cloud is with a product from Microsoft called Azure Data Box. And I've actually included, this is an image from Microsoft's website of what one of the Data Box products actually looks like. And it looks like a big external hard drive. And so what you would do in this scenario is take the files that you've created from your existing data warehouse, and you load those files onto the data box. And again, you think of that as just external storage. You then ship that box, this external drive, and then it's actually physically delivered to an Azure data center, where it's brought into the data center, and the files on your data box become available through a storage account. And so the file transfer is literally a delivery truck. But in many cases, that can be faster than trying to pump data through a network connection. There are really three primary varieties of the data box. I've listed them in this table below: data box disk, and data box heavy. And the biggest differences between them are just the capacities and the speed with which data can be loaded to them. So the one that's just called data box has about 80 terabytes of storage available on it. And when it's in your data center, it's connected with a 10 gig connection. So getting the data from the files onto data box can be very fast. So after we've got that full load done, again, during the time it takes to perform that full load, data is still being pumped into our data warehouse. And before we do that final cut over to use the new data warehouse, we want to build a process that's going to incrementally pull changes from the existing data warehouse and kind of synchronize them into the new data warehouse. So I've used a similar high-level data flow diagram as the full load. The biggest difference here is on step one, where I'm only pulling the deltas or the changes from my existing data warehouse. And so on a regular basis, this will be a much smaller data set, and we can run this as frequently as we need to. But the pattern generally would be the same, where I'm creating delimited text files or Parquet files and putting them to data lake storage. And now from there, I'm merging or upserting that data into my data warehouse. So step three, there certainly is some logic required to do that merge operation, the insert else update. But that's something to consider as you're looking at doing the migration of a data warehouse to Azure. One variation I called out here is that in many cases, particularly as we're getting into just regular ETL, which we'll talk about in a second, is I can create the extract files directly on data lake storage. The biggest consideration there is generally just the size of the files, right? If my files are sufficiently small on an incremental basis, it's entirely feasible to, and I'm looking at this dotted black line here, it's entirely feasible to create those files all in one motion with an extract of data from the data warehouse and then creating those files directly on Data Lake, which saves me the step of exporting them locally and then copying them up to Data Lake. But the high-level process flow there is still similar, but I'm just only pulling those deltas or those changes from the existing data warehouse. This is one way to do this. We've also seen clients that very early on in the migration process just start extracting data from their source system. So depending upon how your source extracts work today, you might be able to take advantage of those same extracts and just load them to two different places. You could load that extract to your existing data warehouse and then kind of simultaneously load that same file from your source to your new data warehouse. But what I've illustrated here is another way to do that, pulling the data right from the warehouse. So moving on to, so we've got the data migration working, all our data is moved, and both the existing data warehouse is being synchronized with the new one. Thinking about kind of the future state of switching over your ETL to load to the new data warehouse instead of the old one. And so the first thing that we wanted to consider there would be which tool do you want to use to do that ETL work. You can, of course, in most cases, use your existing tools. They may require, and most likely will require, some changes to the processes as we're loading a new database platform. But any kind of logic you would have there, mechanisms you're using to control or log the process, you can still use most of that work. Just switch it over to use the new database. So using your existing tool is fine. Very frequently, we are using Azure Data Factory. Data Factory is a really great tool. It's based on a serverless architecture running in Azure. It integrates very well with Azure services. So I talked about Data Lake. It integrates well with Data Lake, has really easy connections to the different SQL platforms. And we use it pretty typically, kind of like you would use SSIS, where we do a lot of SQL execution, so running stored procedures, et cetera. But recently, they've introduced what they call data flows, which is very similar to the data flow capability that we have in SSIS today. And so with that, that's really made Data Factory even a more appealing tool than it was a year ago, and certainly 2 or 3 years ago. So Data Factory is a good tool, and we would consider using that and switching ETL to use that as your database moves to Azure. And then after you've got your ETL tool selected, of course, we need to build the ETL. And my first point there, we do try to reuse as much logic as we can. We don't want to necessarily reinvent everything because we're just switching database platforms. And so a lot of the logic you have, in fact, much of the code can be the same for pulling data out of your sources. So things like your incremental extract logic, understanding when was the last time my data ran and how far back in time do I have to go to pull it. We can reuse a lot of that. Where it does change would be the downstream of actually loading the data warehouse itself in Azure. And I called out a couple things here talking about SQL database versus SQL data warehouse or Synapse. There definitely are some different load patterns that are preferred. And specifically talking about Synapse or SQL data warehouse, the techniques that we use to load Synapse are quite a lot different than just simply pumping data into tables. And a lot of that has to do with the parallel processing architecture underneath there. So without going into a whole talk about the differences there are just some considerations for loading DW that are sometimes different than what we're used to with loading other database platforms. And if we are kind of redoing the way we're doing our ETL, very often we're looking at what we call this modern cloud architecture, and Microsoft has published a number of reference architectures, something similar to what I've diagrammed here on the bottom of the screen, where we've got a process that takes data from our source systems and loads it into files that we store either in blob storage or in data lake storage. And that process of doing that extraction and getting the data into Azure is one separate process. Once that data is extracted into files, then we move on to the second step, which is reading the data from those files and then doing the load into the data warehouse. And very typically, we'll, as I've indicated in the diagram, break those into two separate processes. They're loosely aware of each other, but we try to isolate the process of extraction from that process of loading the data warehouse. And that's just part of what we call this modern cloud architecture. And of course, if we're loading a new data warehouse, we want all of our reports and any other tool that's consuming data out of our data warehouse will need to be, adjusted to use our new schema. And so some of the things here I've listed as considerations are pretty obvious. You want to make sure that you've got connectivity and you're able to authenticate to your new data warehouse. That should go without saying. But a lot of the work that we see with report conversions or switching to using a new data warehouse comes down to SQL syntax. So again, things like the cross-database join that I mentioned earlier, but also just some nuances in the way that the SQL language is different on one database platform from SQL Server. That's generally where we see a lot of the work here is in adjusting that syntax. The other thing to really consider and think hard about as you're planning a migration like this is just the sheer volume of reports. And then, which gets into my last point that I've listed here. A lot of organizations kind of get to the point where they have to decide, do I really want to rework all my existing reports and make all these changes? Or am I better off maybe re-platforming them, moving them to a different tool, or developing them with a different pattern? A lot of organizations actually kind of take that opportunity to take stock and which reports are used, which ones are not used, do we need to migrate all of these, et cetera. So the challenge with the reporting changes really generally comes down to just the sheer volume. The database structure, your star schema hopefully is still the same. It's still the same data. You haven't really added anything. It's just a matter of switching the volume of reports you have over to use that new platform from the old one. And then after you've got all that development work done, your data warehouse is being synced to the new one. It's really time to make that switch where I go from looking like this, where my ETL process is loading what I've labeled my existing data warehouse, and we kind of switch it over to now my ETL process is loading the new data warehouse, and I've got my reports pulling from the new data warehouse. If you have separate ETL processes, it's still feasible if you want to continue to load your legacy data warehouse the way that you were doing and kind of run them in parallel for a time to make sure that everything's working. It's kind of a test ground there before you completely shut down the legacy environment. But this is one example of what your end state could look like, where you're now loading your data warehouse in Azure, and you're consuming reports and analysis out of that data warehouse from Azure as well. So this can be a little bit overwhelming. There are a lot of things to consider here, but Pragmatic Works can help with this. And so this is a lot of what we do is helping organizations migrate to Azure, and so we can help with the ways that I've outlined here. So certainly helping to kind of plan your deployment, plan that migration. We can do a lot of work to help you with the data warehouse architecture, certainly getting into doing the data migration, and also switching over your ETL and reporting. So if that's something you'd like to learn more about, please reach out and let us know. We would really enjoy talking with you about that. And as some of our questions at the beginning of our session alluded to, we do realize that a lot of businesses do have challenges with maintaining databases, and especially if you're moving to Azure and it's kind of new to you, you may not have all of the expertise that you need, and your team and staff might be a little bit shorthanded or stretched thin at times. And so we understand that this is a challenge for many businesses and organizations. And so something that Pragmatic Works is introducing this year is what we're calling our DBA managed service. And this is a way for you to kind of share that workload of some of the database administration tasks, particularly, again, if your team is thin or short-staffed, or even if you just need a little bit of expertise from time to time. This is a service that Pragmatic Works is now offering. And if you have any questions about that, please reach out to us. We would love to talk with you about that. And Crystal, with that, I do want to thank everybody for their time today and for joining me on this session. And I've got a few minutes to take questions if there are any.
Let me check here. I think you might have quite a bit. Let me see. Someone's asking, Alan, you're asking if the recording will be available. Yes, the recorder will be available tomorrow. You can view any of our past or present webinars on our YouTube page, and you will also get the recording link in your email tomorrow. So just stand by for that. You should get it around noon our time, Eastern Standard Time. Next question is, can SSIS projects be imported into Azure Data Factory, or do processes have to be rebuilt from scratch?
SSIS can absolutely be used from Data Factory. In fact, we do have a webinar out there about exactly how to do that. So the only thing in general that has to change is really just the connection to point to the new database. So yeah, your existing packages can be uploaded into Data Factory. And you, again, might have to make a couple small changes, but by and large, that migration it works very well.
Okay. Next question is, does Azure DW use columnar storage?
It can, yes. That was part of the reason I mentioned the 60 million rows. And that was one of the considerations that you'll want to keep in mind if you are moving to SQL Data Warehouse is, should I use the columnar storage or should I continue with row storage? And that would just depend on, the type of table it is and the volume of data that you have. But the answer is absolutely yes, you can use columnar storage in SQL Data Warehouse.
Do we stage unstructured data in Data Lake and use it with Azure DW for reporting?
You can, yeah. So that was part of this idea. I'm going to flip back a couple slides here. This modern cloud architecture, the answer to the question is yes. This is part of the reason we do this, is that the data that I have stored in these files here, of course, we are using this data to load into the data warehouse, but any tool that has access to read files from Data Lake can be used to, consume that. So things like if you want to do some Databricks analysis on it, if you want to, depending on the file type, there's some limitations, but in concept, you can put Power BI against that and look at that data. But that is part of the benefit of this pattern, is that the files can be used for any number of types of analysis you want.
Next question is, does Pragmatic Works have a training for Azure Synopsys? Bob, can you still hear me?
Sorry, yeah, I can hear you. The answer, I don't know if we have a training course on Synapse or not. I can look at that very quickly, but offhand, I'm not sure.
Okay. Um, could you please repeat the SQL DB versus managed instance?
Yes. So I'm going to flip back here. So typically, from a migration standpoint, I'm going to use managed instance. Let me say it this way. In managed instance, you have support for using a SQL Server backup and restore, very similar to what you would do today with on-premises SQL Server. Using SQL database, though, I cannot take a backup like we consider it today from a SQL Server database and simply restore it in Azure SQL DB. Now, I have the option of doing what's called a backpack, which is a file that includes the data structure and all of the data. I can use that to migrate a database from on-premises to Azure SQL DB. That doesn't generally work very well for anything over about 200 gigs. It's just the time it takes to create that file, the process of uploading that file to Azure and then deploying it generally doesn't work that well for larger databases. So when we're talking about a data warehouse, generally speaking, that backpack approach of migration to SQL DB is just not a consideration.
Okay, given how SQL DW is built by a compute, excuse me, a compute, and that is how it scales, is the execution of reports considered compute as well?
The individual execution of a report is not, but SQL Data Warehouse is just billed for the time that the service is up and running. So regardless of what it's doing, whether it's processing an ETL load or people are running reports against it, what I'm doing with it doesn't impact the pricing. It's just the time that the service is up and running impacts pricing.
Next question. As you move source files to data lake, like Parquet format, I'm going to say it is.
Mm-hmm. Yep.
How do you reconcile from this raw zone to the DW/stars schema type layer?
Right. Uh-huh. How do we, what was the question? How do we
reconcile?
Mm-hmm. Yeah, I mean, that's a good question. I mean, that's just a data validation question of, running queries against your data warehouse and running queries against your, your existing warehouse. The other thing you can do, though, is if you wanted, I mean, yeah, you could do some Power BI analysis on it, or you could use something like Databricks to summarize the data in those files and use that to generate kind of a summary of what's in the files, and then query your data warehouse. And now you've got kind of the two results, and you can compare them side by side.
Question here. Okay, what is the difference between the training and the help? Is that just a selling point?
Let me go into the training and the help. I might have to take that one offline. Maybe I'll reach out to that person. I'm not sure I'm not sure I understand the question specifically.
Okay, not a problem. Do we have an option to migrate from SSIS to ADF?
Yes, I alluded to that earlier. SSIS, you can just run your SSIS packages from Azure. And so that's just more of a kind of a lift and shift approach. What we don't really have is like a conversion of taking your packages and making them into Data Factory pipelines or data flows, as we call them. We don't have that path, but again, SSIS packages can absolutely be run from within Data Factory. And Crystal, I'll take just one or two more then, if that's all right.
Yeah, no problem. Let me see
okay.
What we have. Okay. Should one not be looking to take advantage of Polybase? Would it make more sense to opt for SQLDB with hyperscale as opposed to using SQLDW for the cost savings with a DW under 1 TB?
Sure. Yes, that's definitely an option. Yes. Yeah, I'm going back to my in here. Yes, I mean, and this here. Yes, that's definitely an option. What I would say on we see a lot, and so you mentioned the 1 terabyte. Synapse SQL Data Warehouse is incredibly powerful for things larger than that. So when you're into the multi-terabytes, is where you really want to look at Synapse SQL DW. You can absolutely use SQL Database for a database of that size, as the person asked. These are just kind of some guidelines that we help us kind of frame that discussion. But the answer to the question is yes, you could use that. I'll take one more then, Crystal.
Okay, let's see. Are the packages executed as a process when uploaded to Data Factory, or would it be executed as a package itself?
So yeah, the way that works, and again, I would suggest that we do have a webinar on this topic. The way that it works is from within an Azure Data Factory pipeline, there is a pipeline activity that's called execute an SSIS package. And so from that activity, you simply point to the SSIS package that you want to execute, and then that package is executed within a Data Factory pipeline. That's how that works.
All right, perfect.
I hope that helps there. And if there are others, yeah, Crystal, if there are others, of course, I'll try to get those into a follow-up blog post at some point if there are others.
Yeah. You have maybe about 7 more here. So
okay.
Well, I'll send them over to you. That way we can go ahead and follow up with everybody.
Yes. Okay. Thank you.
All right. Thank you, Bob, so much for hosting. As always, we appreciate it. As for everybody else, like I said before, the recording will be available tomorrow around noon Eastern Standard Time. But if you guys have any questions, like Bob stated, please feel free to reach out to Bob or myself. If you guys have any questions about DBA Managed Services, please feel free to reach out to us about that as well. You guys will receive the link tomorrow in your email, so stay tuned for that. And like I said, you guys can view all of our present, past webinars on our YouTube channel at Pragmatic Works. Thank you guys so much for joining, and we appreciate it. We hope you guys have a wonderful rest of your Tuesday, whether it's in the morning or the evening. You guys have a great day. Thanks so much. Bye-bye.